Okay, let's take a look at compact and spongy bone a little bit more. Then we're going to move into some other topics. So this is kind of your book's drawing of, again, just kind of a chunk of this bone. We talked a little bit about this before, but let's remind ourselves that the compact bone is going to be, as it suggests, very compact, made up largely of osteons. So you should remember that osteons are kind of the fundamental units of compact bone. Towards the center of the bone, we get into the spongy bone, and the functional kind of units of compact bone are called trabeculae. So a trabecula is kind of a rod shape. So these are kind of the rod portions here that then form the spaces. So we want to think of osteons with compact bone. Surrounding that compact bone would be the periosteum. And then on the inside is the spongy bone formed by the trabeculae, and covering those trabeculae is the endosteum. This is your book's version, just getting a little more detailed. We're now taking, one of those osteons, and we can see it as kind of this layered cylinder with a central canal right in the middle. These little dots in here are the actual osteocytes. Those are those bone cells, and they sit in these little compartments called a lacuna. If you remember, we learned about those in cartilage as well. So that's kind of the cross section of an osteon. That's an actual image. Here's a drawing. Notice it's got these layers called lamella. Concentric lamella are these kind of cylindrical layers to that osteon. Trabeculae, again, they kind of pull out the spongy bone here, and you can see that trabeculae that would be covered with the endosteum. Here's an actual image of that spongy bone. If you were to cut through one of those trabecula, you'd also see kind of this layered pattern with the osteocytes kind of embedded in between those layers. And one final note, these spaces, again, would be where you're going to find red bone marrow. All right, next topic is bone formation. So bone formation, or ossification, or osteogenesis is the process of making bone tissue. Formation of bone tissue occurs in a number of situations. Obviously, number one is forming the bone during embryonic and fetal development. You have to initially form the bone, and then you have to grow the bone. So obviously, these bones, once they're formed, you have to keep making bone tissue in order for them to grow, and then continue to grow up until adulthood. We also can't forget, the process of remodeling. So you have to be able to make bone during remodeling, because you're breaking bone down with the osteoclasts. You still have to build bone or form bone with your osteoblasts. And then finally, in order to heal a fracture, you have to be able to form new bone tissue that in essence kind of acts as glue to glue it back together. We're going to learn about two forms of ossification that occurred during embryonic and fetal development. So these are the two forms of ossification that make the bone. All right. And the difference is due to what kind of bone it is. If it is a flat bone, they form by intramembranous ossification. So that occurs in flat bones when you have a connective tissue membrane that is then replaced by bone tissue. So you start off with a membrane, and then as it forms, you basically replace it with bone tissue, and that becomes a flat bone. Endochondrial, the key here is to know what chondral means. Chondral means cartilage. So you're not doing a connective tissue membrane. you're making cartilage first. So you form kind of a cartilage model of the bone, and then that eventually converts to bone tissue. All right, and this is how we would form long bones of the skeleton. So let's look at intramembranous ossification. So flat bones, for example, these flat bones of the skull, are first made using membranes. So you can kind of see here that you would have, let's see, kind of a membrane here and a membrane here. And then in between, eventually in between those membranes, you actually form the bone matrix, the bone tissue. All right. So the key here is flat bones, such as those of the skull. You make a couple membrane sheets first, and then you fill in between those membranes with the bone tissue. One thing that's kind of connected to this are the soft spots. So soft spots in a baby's skull, known as fontanelles, are the membranes that haven't ossified yet. So these are the connective tissue membranes, but they haven't ossified. It's still just the membrane. And what that allows is the skull to be able to fit down the birth canal. So that causes the skull to be very flexible, and it allows that skull to expand, all right? Because these membranes will actually grow, allow the skull to grow, and then eventually those membranes completely convert to bone tissue, and what's left where those membranes are the sutures. All right, so we'll learn about sutures when we get to the skull, but a suture is an immovable joint between flat bones of the skull. So where this membrane or this fontanelle was, eventually it's going to form the sagittal suture. Where this membrane is, it's going to form what's called the coronal suture. All right. So flat spots or fontanelles of a baby's skull are the membranes that haven't ossified during intramembranous ossification. Endochondrial, again, you start with cartilage. That's the key difference. So here's a cartilage model. So it kind of looks kind of shaped like a bone, but it's all cartilage. In this stage here, most of that is what we call uncalcified cartilage. Then it starts to grow. You'll notice it gets a little bigger. It forms what's called the bone collar. We're not going to really get into that much. But notice all of a sudden there's what's called a primary ossification center. So the cartilage that was here is being replaced with bone tissue. And as we continue through the process, there's a secondary ossification here. So notice we start to form bone through that diaphysis or shaft. Then we start to form bone in the epiphysis. And what that leaves is a little layer of cartilage here, which is going to be the epiphyseal plate or growth plate. So as long as you leave cartilage here, this bone will still be able to grow in length. Eventually, notice here is an adult bone, and there's no cartilage, and therefore it's called an epiphyseal line. All right? So this process here, where we form a bone from a cartilage model, is called endochondral ossification. Now we got to look at how the bone grows in length, and we've kind of talked about this process. So here's that bone. Notice it says childhood to adolescence, so the bone is still growing in length. There's the epiphyseal plate or growth plate. This light blue represents cartilage, so we still have cartilage. This is where the primary ossification center was. This was that secondary. All right. This process is called interstitial cartilage growth, or just interstitial growth. The word interstitial means in between. So we're growing in between the epiphysis and the diaphysis. And as long as there's cartilage there, this bone can still grow in length. Once this completely converts over to bone, no more growing in length. All right, this is an X-ray. You'll see that cartilage doesn't show up as white in an X-ray. So this is bone here. This is bone. There's an epiphyseal plate. This looks like the distal end of the femur. And then this is the proximal end of the tibia. And the tibia is growing with that growth plate right there. So this tells us that, obviously a 3-year-old is still growing, but those two bones have nice growth plates. Growth in width is called oppositional or appositional growth. And this is basically making the medullary cavity bigger by dissolving the inner surface using osteoclasts, but then building more bone on the outer surface with the osteoblasts. So notice here's an infant's bone. The diameter is pretty small. Here we see that the cavity is getting bigger. All right, notice we're doing bone resorption using osteoclasts. So they dissolve that inner layer, right, making the cavity bigger. But as the cavity gets bigger, you build more bone, so bone deposited by the osteoblasts on the outer surface. So you're hollowing out the inside, adding bone to the outside, and that's how a bone will grow in width. So now we got long bones that can grow in width and that can grow in length. I think we're going to do calcium homeostasis in the next video. This is probably the trickiest slide, but it's probably the most important slide. We're going to be talking about how we maintain adequate blood calcium levels using 2 different hormones. All right, so this is introducing a couple hormones. We have yet to learn about specific hormones. So these will be our first 2 hormones in anatomy and physiology. So take a break if you need it, because we want to be 100% engaged and focused when we're going through calcium homeostasis.